This video will provide a comprehensive guide to writing clean, efficient, and maintainable JavaScript code. We will explore various best practices to help you improve your coding skills. Best practices help create code that is easier to understand, maintain, and scale. They reduce technical debt and improve collaboration across development teams. In this video, we will be covering code organization, naming conventions, performance optimization, security considerations, and maintainability principles. Let's start with code organization, specifically project structure. It's essential to organize your JavaScript projects into logical modules and follow a consistent directory structure. This enhances maintainability and scalability. Benefits include improved code reusability, better dependency management, and easier testing and debugging. A typical project might have a source directory containing components, services, configuration, and test directories, along with a package.json file at the root level. Now let's look at module patterns. Here are two common approaches: the module pattern and modern ES modules. In the module pattern, we create a self-executing function that contains private variables and methods along with a public API. In this example, the base URL and format user methods are private, while the getUser method is public. In the modern ES module pattern, we use import and export statements such as import format date from utils.js. Class properties are defined using the hash symbol, and methods are defined as class functions. Next, let's discuss naming conventions. Consistent naming makes your code more readable and maintainable. It is recommended to use camel case for variables and functions, Pascal case for classes and constructors, and uppercase for constants. You should always choose descriptive and meaningful names, avoiding abbreviations unless they are commonly known. Also, use verb prefixes like get, set, is, or has for functions. For example, instead of just using x as a variable name, use item count, and instead of just calc, use calculate total price. Similarly, class names should be descriptive, and in Pascal case and constants should be all uppercase with underscores. Moving on to advanced naming patterns. Boolean variables and functions should start with is, has, can, or should. Asynchronous operations should end with async, fetch, get, or query, and event handlers should begin with handle or on. For example, a variable that determines whether a user is active could be named isActive. Similarly, a function that retrieves the data of a user could be named fetchUserData. An event handler function would be named handleSubmit. Now let's explore some performance optimization techniques. To improve performance, use array methods instead of loops. This improves readability and performance. Also, cache DOM queries and array lengths in loops. Avoid unnecessary object property access. Use modern array methods for data transformation, and leverage destructuring for cleaner property access. Here's an example. Instead of using loops to filter and map arrays, chain array methods like filter and map. Also, instead of repeatedly accessing nested properties, you can use destructuring to extract them into separate variables. Now let's discuss memory management, which is crucial for optimizing performance. Memory leaks can degrade performance. Common sources include event listeners, closures, and timers. You must always remove event listeners. Be careful with references and callbacks, and clear intervals and timeouts. Also, avoid global variables and implement proper cleanup in components. You can use weak map or weak set for object references to help reduce memory usage. Here is an example of how to use remove event listener and clear interval when the component is no longer in use. Now let's talk about security. One of the most important security practices is input validation. You should always validate and sanitize user input before processing it. Never trust client-side validation alone. Also, use Content Security Policy or CSP headers. Always implement proper encoding for dynamic content. Here's an example: a method that trims input, removes angle brackets, and limits the length of the string. Another method shows how to sanitize HTML to prevent XSS attacks. Moving on to secure data management. Always encrypt sensitive data before storage or transmission. Also, use secure token storage and refresh mechanisms. Implement secure session timeouts and regeneration. Here is an example of authentication. Notice the use of secure storage for the auth token with HTTP-only options and a token refresh timer to keep the authentication active without asking the user to log in repeatedly. Finally, let's discuss maintainability. Applying solid principles will lead to more robust and maintainable code. The single responsibility principle states that each module or class should have one, and only one reason to change. The open-close principle says that software entities should be open for extension but closed for modification. Following these principles makes it easier to test and debug code, easier to understand and modify the code, and leads to more reusable components. As an example, the report generator class is dependent on the formatter class. This means you can easily extend the report generator to work with new formatters such as PDF or HTML, without modifying the report generator class itself. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.